All right, today we're going to be looking at the second part of 11.3, digging a little deeper into matrices. And we can see right here off the beginning, matrices are considered to be equal if they have the same size, that's important, and each corresponding entry is the same. In order to add or subtract matrices of the same size, and that's the big thing, is that they must be the same size in order to add or subtract them. We're just going to add or subtract the corresponding entries. In order to multiply a matrix by a scalar, which is a real number, we're just going to multiply each entry by that particular scalar number. What I would do for this is basically just think you're going to distribute a number that's in front to each item inside the matrix. Okay, so that's what we're looking for that. Some more properties I can show you. You can see here, if you take two constants, you can multiply them together first before you multiply the matrix by that. And as we talked about, there's the constant in front. We can distribute to each of those matrices that are there and then add the matrices together if needed. Some other just vocabulary right here. A zero matrix is a matrix where all entries are zero. It's the additive identity for all matrices of the same size. You can read about a row vector, where it's just a matrix with one row. I see I fixed it right there. A column vector is a matrix with one column. Now, the big challenge here will be matrix multiplication if you've never done this before. What you're going to do is multiply matrices. You want the number of columns in the first matrix must be the same as the number of rows in the second matrix. So think about it this way. If I have row 1, column, right? If I'm looking at that, so look at a matrix 1, we'll call it. And we got a row by column for the matrix 1. And we want to multiply that with a second matrix. Okay? So what we're going to look for is right here in the middle, is that these two spots must match in order to multiply. If they do not match, you cannot multiply the two matrices together. We'll see one of those examples in a little bit. All right? But we're going to practice multiplication today. We'll go through the whole process. So let's get after these examples. First example, we got a nice easy addition one right here. As we talked about, they're both 2 by 2 matrices, 2 rows, 2 columns, in case you forgot from yesterday. And when I look at that part, so they are the same, so I can add them. So I take matrix A, which is 2, 3, negative 1, and 4. I want to add that to matrix B, which is 1, negative 1, 3, and 0. As we said, so the same size, we're just going to add the same entries, meaning first row, first column, we have a 2 and a 1. If we add that together, we get 3. That stays in the first row and the first column. First row, second column, I got a 3 and negative 1. When I add those together, I get a 2, and that stays in the first row, second column. Now when I add there in the bottom left, I have negative 1 plus 3. So I'm going to get 2 in my second row, first column. And then adding the last spots, 4 plus 0, I get 4. As you can see, because you added the same size matrices, you are going to get the same size matrix back. In number 2, now we're doing some multiplying. So we have a 2, 3, negative 1, 4. We are now going to multiply times 1, negative 1, 3, and 0. I'm multiplying here, as we said, a 2 by 2 matrix with another 2 by 2 matrix. Since these match, then I can multiply them together. The nice thing is, whatever's on the outside here, those values, that is the size of the matrix I will get when I am all done. So you kind of get a little foreshadowing what you're going to see when you start multiplying here. So as we get going here, I know it's going to be a 2 by 2. It's really simply, I'm going to take this first row of the first matrix times the first column of the second matrix. And I'm going to match things up and multiply. So I'm going to take 2, because that's the first spot of that row, times the first spot in the column. I'm going to add that to the second spot of that row times the second spot in that column. So when adding those together, I'm going to simply just get 2 plus 9, which gives me 11, and that goes in the first row of the first column. If I do it again, first row, now we're going to do that times the second column. So first spot times the first spot in the second column, and then I'm going to take the 3 from that first row times the second spot in that second column. When I multiply these, I get -2. And because I did first row, second column, that's exactly where that number goes. So now I finished the first column. As you can see, we have 2 spots right there. I'm going to do the second row. So I'm going to take -1 times 3 and add that to 4 times 0. Again, first spots get multiplied together. Second spots get multiplied together. When I multiply that, I'm going to, I'm going to say times 1, my fault. And that's we have there. This one's a 3. I'm going to jump ahead a little bit. Get a little excited. Jump to the next problem. So I got 11. That's a coincidence. That does not always happen. Now I want to use that second column. Jumped ahead a little bit there. So -1, -1. And then I got the 4 times the 0. So when I go through and I multiply and I add those pieces together, I'm going to get +1. And there, because that was the second row, second column, that is the one that I'm going to put into that corresponding spot. So now what I need to do is I want to add the 2 matrices together. And so when you look here at adding the matrices together, here's the problem. I have a 2 by 3 matrix, but I want to add that to a 3 by 2 matrix. Since these are not the same, right? Since they have different sizes, they cannot be added. All right? And so you can go from there and finish at that spot. All right, let's take a look at the second page now. So here we go. We got some addition of matrices again. We're going to look at and say, okay, if we have matrix A, which we see is a 2, 3, -1, 4, plus we got parentheses, matrix B, 1, -1, 3, 0, plus matrix C, 1, 0, 0, 1. That's the additive identity matrix. You'll worry about that later. But anyways, they're all 2 by 2, so I know that I can add them together as we go, but obviously order of operations tells me that I need to add the last 2 together first. So I'm going to match things up. So 1 and 1 in the top left corners become 2. First row, second column, -1 and 0 becomes -1. 3 plus 0 for the second row, first column gives me a 3. And then 0 plus 1 obviously gives me a 1 for that spot. So by adding those 2 together, I was able to come up with that. Now I can add the first matrix in there, and we can say, okay, 2 plus 2 in the top left corner, or the first row, first column, gives me a 4. First row, second column will give me a 2. And then the -1 plus the 3 for the bottom left gives me a 2. And then I also have the 4 and the 1, which gives me a 5. And there is my sum of those 3 matrices together. Now, as you looked at multiplication, we were talking about this earlier. If you look at matrix D is a 2 by 3 matrix, but it's asking me to multiply by matrix C, which is a 2 by 2 matrix. As we mentioned before on the front side, these do not match, right? So since there is no match, that is right there, right? Since these spots do not match, okay, then you cannot multiply the matrices. The important thing I should say is multiply these matrices in this order. Because technically, if instead I asked you to multiply C times D, they would match. And then you could multiply. So that's a little interesting thing to think about there. All right, so now we got number 6, which we know that we have A times A squared is really means the same thing as just doing A times A times A. But obviously we know our order of operations is telling us that the squared has to come first. So basically we're just going to multiply these 2 matrices together, right? The order of operations is telling us that we need to do that. So by looking at this, I have 2, 3, -1 and 4 times 2, 3, -1 and 4 times again 2, 3, -1 and 4. So it's the same matrix over and over again, but because of that squared, that's implying these two need to multiply first, and it makes a huge difference with matrices. The order does matter. So you need to make sure you follow, if there's an order to them, follow that order when you are going through and doing your multiplication. All right, so I'm going to leave this first matrix alone because we haven't used it yet. It's coming along for the ride here to get started. But I do need to multiply these two that are inside the parentheses together. Just like we did on the front side, I'm going to take the first row, multiply it with the first column. So off the side, if you want to do this, we're taking 2 times 2. Oops. 2 times 2 plus, I'm going to look at that second position times the other second position. When I multiply and add those carefully, I get a 1, and that is going to go in the first row, first column. Same thing, first row, second column. So I have a 2 by 3, or 2 times 3, sorry, plus 3 times 4. So multiplying that together, I get 18. So that's going to be in the first row, second column of that green matrix. Now I'm done with that particular row, so I'm going to go to the row underneath. So I have -1 is the first spot, 2 is the first spot in that first column. And then I'm going to say, okay, now I have 4 times -1. So -2, -4, be careful with your negative signs. And we have -6. Since that was the second row, first column, that's exactly where that -6 goes. And then do it one more time, -1 times 3, because now I'm going to use the second column. And then I have 4 times 4, again with that second column, second spots there. So I can multiply -3 and 16, gives me 13. And there we go. So just multiplying that second group of matrices from the quantity squared, I end up with that green matrix that's listed right there, the 118, -6, and 13. It's still a 2 by 2. So therefore, I can still multiply those together. And so if we go from here, and we'll go ahead and we'll go red this time, right? Change up the color a little bit. So I have first row, first column that I'm going to go here. And I'm going to say, all right, I have 2 times the first spot of 1 plus 3 is the second spot times the -6 for the second spot. So 2 minus 18 gives me -16. So first row, first column, because that's what I was multiplying together. First row, now second column. So 2 times 18. Second spots were 3 and 13. Now this one without a calculator, just be careful. 2 times 18 gives me 36. 3 times 13 gives me 39. So ultimately, altogether, I have 75. First row, second column. There you go. I finished it out because 2 by 2 is going to give me a 2 by 2 at the end. All right, we multiply those. So now I'm going to use the second row. So -1, I'm back to the first column. So -1 times 1 plus 4 times -6. Again, just be careful. Make sure you got -1 minus 24 gives you -25, which you're going to put in the second row, first column, because that's what we multiplied. And then if I take that bottom row, second column there, I'm going to take -1 for the first spot. And then the first spot in that last column was an 18. And then I have the 4 is the second spot times a 13, which is the second spot in that column. And so we're going to say, all right, again, be careful with your multiplying. We have -18 plus 52, like 52 cards in a deck, right? Because there are 4 suits of 13 cards in each suit, gives you 52, right? So if I add all those together, and be careful, and I get 34, because I multiplied the second row, second column, you will get 34 as your last spot. And there is your matrix multiplication. If you got any questions, rewatch the video, ask your teachers, and good luck.